All right, so looking at lesson 123, general conic equations. What are the conics that we've looked at so far? Circle? No, not a cone. Ellipse, a parabola, and a hyperbola. Those are the four. And we're going to be looking at the general equation for conics. That is the general equation. ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. We don't always have all of the terms. For a parabola, we're missing the y squared term, right? It's only x squared, and we're also missing the xy term. So for parabola, you take out these two terms. You don't have a xy or a y squared. For a circle, you have x squared plus y squared. You have your x and your y, and you have an f. And for a circle, remember that your a and your c, these two numbers have to be the same. So remember that? Because if they weren't the same, what would it make it? An ellipse. Okay, so your ellipse is really similar, but your a and your c, they're just not the same. They're both going to be positive, or technically they both could be negative, and you can move everything over to the other side and make them both positive. But remember, we want our ellipse, both of them, to be positive. And then a hyperbola, we have our x squared and our y squared terms. Our a is positive and our c is negative, or our c is positive and our a is negative. So far for all four of these, have any of them had this xy term? Have we dealt with an xy term at all? No. And Saxon said that when we're dealing with these, we're not going to have an xy. You can do it, but he's just not going to teach us how to do it. Except for on this lesson, we're going to look at just one example. So you don't have to write this part, but what we're looking at, no, wait, yes you do. Sorry, this is the one you have to write. We're looking at one so that you are not degenerate. And if it's a degenerate conic, it means that it's like, basically, it makes a point, it makes a line, it makes parallel lines, intersecting lines, or no graph at all. It doesn't make an ellipse, circle, parabola, or hyperbola. So all of these that they've given us so far actually make an equation. It makes a graph. They haven't been mean and given us a graph that doesn't really work. Yeah, not lone. It should be line. Thanks, Scott. So here's an example of a degenerate conic. X squared plus y squared equals 0. Why is it a degenerate conic? Because why? It's just a point. Why is it just a point? It's a circle with no radius, right? It's just at the origin. So that's an example of a degenerate. They've been nice and they haven't given us degenerates, right? Everything, I mean, whether we knew how to graph them or not, they did actually make a graph. Does that make sense? Okay. So what we're going to look at with ones that have the XY term, you may not really be able to tell on this picture on the left, but this middle one, do you see how it's an ellipse but it's like tilted? And so do you see how it's like rotated hyperbolas? Does that make sense? That's what we're going to look at with the XY. Do what? Okay. So we're going to look at really easy versions of this. Just XY. Alright, so what we're looking for are numbers that multiply to give you -4, right? So let's pick some numbers for x. What numbers do you want to pick for x? 1, -2. Do you want to pick 3? Would that be a good one to pick? Okay, what else? +2, -1. 4, -4. I'll pick 0, because y'all don't want to pick it. We'll get there, we'll get there. Okay, if you plug in 1, what do you get for y? Okay, if you plug in -2. If you plug in 2, -1, 4, -4, 0. Undefined, right? Does not exist. Okay, so now we go and plot our points, right? So I plot 1 point. I plot another point. I plot another one. I plot another one. Another one. Another one. Right? But at 0, what does it do? No, it's not a hole. It's an asymptote. Does that make sense? So it doesn't work there? Okay, so what does our graph look like? That's one end, and then I didn't exactly go through my points, but does that make sense? Do you see how if I'll do it in another color so you can see it. Do you see the asymptotes that are our diagonals? One that's vertical, I mean, I know I didn't draw it exactly right, and then one that's horizontal, like it took it and tilted it. Does that make sense? And they can take them and move them around, but he's not going to be that mean to us this year. We're only going to have ones that look like that. They're centered at the origin. Do y'all see how they work, though? Not too bad? Okay. So this is a hyperbola that's been, like, tilted. All right. So this is what they like to do next year especially. They'll give you a bunch of equations and tell you to tell whether they're a circle, parabola, an ellipse, or a hyperbola. Does that make sense? You got to figure out looking at the equation of them. So if you look at the first one, what are we going to be looking at to tell what it is? The what? Yeah? Which term is going to help us the most? The 2y? What else? No, the 3x isn't important. The 2y and the x squared. What equation only has a y and an x squared? Does a circle have a y and an x squared? What about an ellipse? Or a hyperbola? It's just the parabola. Okay? Because we could tell that from these two terms. Looking at the second one, what terms do we want to look at? So which one? I can't hear you, Scott. What? No, we don't really care so much about the y on this one. We want to look and see if they have any squares. We've got the 2x squared and the 2y squared. So is that a parabola? No, parabolas only have one squared. Is it a hyperbola? Remember, it's an x squared minus y squared or y squared minus x squared for hyperbola. So it's either going to be an ellipse or a circle. Why is it a circle? Because the number in front is the exact same. Y'all with me so far? Okay, looking at the next one. What numbers are we going to look at? Or what terms, I mean? We're going to look at these two right here. So, is it a hyperbola? Why? Because you got x squared minus y squared. What about this one? What are we going to look at? Are we going to look at this term? What about this term? So they're both positive, so it's either a circle or an ellipse, right? Okay, why is it an ellipse over a circle? Are these two numbers the same? So is it going to have the same radius left and right as it does up and down? Okay, so it makes it an ellipse. Do y'all see how that works? Okay, so now it says tell which is which. We did. Why? I asked y'all to do that. And then write the equation of the ellipse in standard form. So you had to get the ellipse part right. Which one is the ellipse? Just D. And how do we put it in standard form? Y'all been doing that, right? Okay. Oh, Brady. You always say everything is too hard, but then you always do really well. You obviously understand it well enough to make a 35 on your ACT. Huh? Huh? You guessed right on all 60 math problems, all 75 English questions, all 40 Reading and 40 science questions. You know the probability of guessing right on all of those? 1 in a bajillion. Okay.
Excuse me, Ms. Justin.
Yes,
Do you have Scott Daniels?
I do.
The guidance department just for a moment.
Okay. Y'all agree so far? So then what do you do? Divide everything by 36. So you end up with x plus 2 squared over 4 plus y minus 3 squared over 9 equals 1, right? So it says describe it. So what do we know about this ellipse? Okay, the center is negative 2, 3. Okay, what else do we know about ellipse? It is vertical. Why is it vertical? The bigger number is on the y, so it goes up more and down more. Major axis is 6. And that's really, if we're just supposed to describe it, that's really all we know. That's all we can tell about it. Any questions here? Okay. None to omit tonight, unfortunately. I know. It's because we haven't skipped a lesson in a while.